This video goes through how to factor sum and difference of cubes. You do need to remember the formula. The video shows where the formula comes from. I only need you to be able to apply it. So first thing we're going to do is look back on our difference of squares factoring, where we have two brackets, and we're going to take the square of the first term and the square of the last term and set them up so that it is a plus b and then a minus b, where a and b are the square roots, respectively, of the first and last term. So here I've got y plus 9, y minus 9. A little bit trickier on the next one because I've got a more complicated square root to take. So I've got 4y squared minus square root of 81 is 9x. And then I've got 4y squared plus 9x. Can't factor any further because the x is not a perfect square. The last one, so this is just in general, a plus b and a minus b, which is what I said earlier in the video. So what happens when we have a difference of cubes, which is where our first term and our last term are perfect cubes? So we are going to use polynomial long division to figure this out, and then we're going to state our formula in general. So I'm going to put my divisor out here, and then I'm going to put my long division here, and I'm going to put all of my placeholders in. That's 0x squared y plus 0x y squared minus y cubed, and then I'm going to do my long division. So I've got x cubed divided by x, which is x squared, and then I'm going to multiply back through. X squared times x is x cubed. X squared times minus y is going to be minus x squared y. And then I'm going to subtract. These ones cancel out. And then I'm going to continue on here. So I'm subtracting, really I'm adding that x squared plus y term. And then I'm going to bring down the next one. So I've got 0x y squared. Now I'm going to repeat, starting with my next term. So I've got x squared y divided by x. And then I'm going to be left with x y up here. And then I'm going to multiply back through. So I've got x squared y as my first one. And then I've got minus x y squared. And then I'm going to subtract those two, which is going to leave me with xy squared. And then I'm going to bring down my last term right here. And then I'm going to do one more division, xy squared divided by x, which is going to leave me with y squared. Multiplying back through gives me xy squared minus y cubed, which is 0, which means that x minus y is a factor. And that means that I can write my original division statement. So x cubed minus y cubed as x minus y times x squared plus xy plus y squared. We also have a similar one down here in that we can do the same thing for the other operation, a sum of cubes, and this is just showing you where the formula comes from. If I have x plus y, and then I can put in x cubed plus 0x squared y plus 0xy squared plus y cubed. And then I'm going to start off by doing x cubed divided by x would be x squared. X squared times x is here, plus x squared y. And then I'm going to subtract. Here I get negative x squared y, bringing down my next term. My second step, I'm going to start with minus x squared y divided by x. Maybe you're noticing a difference here. This is going to leave me with minus xy, and then I'm going to multiply back through. So I've got minus x squared y minus xy squared, all over. I'm going to subtract. These ones cancel out. Here I've got xy squared. I'm going to bring down my y cubed at the very end. Last polynomial division is xy squared divided by x, which is going to leave me with y squared. Multiplying back through gives me xy squared plus y cubed. Subtracting leaves me with 0, which makes sense. That is a factor. And that means that I can write x cubed plus y cubed as x plus y times x squared minus xy plus y squared. So in general, my sum of cubes can be factored as, we'll write down both. So difference of cubes is a minus b times a squared plus ab plus b squared. And my sum of cubes is almost exactly the same, except I've got a plus b and then a minus b inside the brackets. You do need to remember those formulas. A and b represent the cube root of the first term and the second term, respectively.